Okay, good afternoon, everyone. Thanks for joining me today. My presentation. I'll be presenting a automated growing tent. Was my project this term. Okay, let's get started. So my problem statement: to design, program, and build an affordable PLC-controlled plant growing system that is self-sustaining, compact, and in order to improve the quality and quantity of the plant's growth and yield within the comfort of one's home. Project description. Grow tents has obviously been around for a while now, but I got the idea from seeing my plants or my vegetable garden at home take strain from the cold weather and infestation of bugs. So I decided on making my own compact and affordable version of a grow tent, as they are all quite costly on the market and not too large for home space or home use. Yeah. So my little bit of background research, didn't do too much, but I found that most of them are need to be attended regularly, watered manually. They need a lot of space. I mean, unless you're going to put in your garage or have a designated room for it, it can be out in the open, stick out like a sore thumb in your house, and most users probably won't want that. Like guests come around and that. And then obviously they're really expensive, and also the lights for grow tents are these like LEDs that are also very costly. So I went for a cheaper alternative, which I'll explain later.
Especially when you break and have to.
Yeah. So how mine works, the grow tent can be set to a specific day and night time, depending on the type of plant that you're growing, and is adjusted with the provided buttons on the interface, which I'll be showing later. The plant will be watered autonomously via a tube connected to a solenoid valve, connected to any water source, and is monitored and controlled by a moisture sensor positioned in the soil. So yeah, here you can see it displays the day and night cycle and when it waters. So here's my function block diagram. So we have 5 inputs. Start at the top here. We have the manual feeding system with just one button pressed, and it has a latching relay. So no, it doesn't have a latching relay, sorry. It has a timer which will just water it for a certain amount of time, and also has a comment block which then displays the watering sign. Then there's also this is all connected to an OR gate, because the moisture sensor also monitors that, and when that hits a certain value, then it will also water it. Then we have the starting sequence. So when you turn on the PLC, it won't start the cycle yet. You have to manually press that, and then it will start the timer sequence that's on and off for whatever times you've set, and that can be changed down here by the 2 other switches. There's the select button, which selects whether you want to go up or down with the cycle, and then you can switch direction on that. But I'll show you on the actual thing later. Okay, then this was just a little 3D print I made for the interface. So the PLC, I extended the wires from the PLC so that it can then fit into the case, and that can then be mounted near the front of the grow tent, displaying all the information. And then it also has 4 push buttons that I've put in. I only found out later that you could actually use the given buttons on the PLC, but you live and you learn. So this is what it looks like here in real life. Under the hood, let's call it, we have the power supply and the one relay, which will then power the solenoid valve, and then the interface over here. So I'm using CFRs, which are compact fluorescent lights. They're quite cheap compared to the standard LEDs, LED grow lights. Especially when you're starting out, you don't want to use you don't want to, you know, buy an expensive light, especially if you're only growing like a small amount of plants, or especially for this scale. It is, however, quite dynamic in the sense that you can purchase higher watt rated CFLs later on, because they all have the same standard sized fittings. So you can, yeah, so that's why I said it was quite scalable. So here's my bill of materials. So yeah, the main cost would probably be the lights. Depends on what rating you're going for. I went for 20 watts each, and they amounted to about 70 rand each. And then obviously the PLC, I only used the PLC for this course just because that's what we were doing this term. I'd switched to a cheaper microcontroller like an Arduino, which is what I was doing at home at the moment. And then, yeah, just the power supply was also quite expensive, about 230 bucks. My successes and difficulties, running the simulation in the Logo software worked well, and it made it really easy for me to test my project and see whether or not it was going to work. My time management was, I think, quite a success, although I was quite stressed whenever I came in on a Wednesday. It's only because I could come in once a week and had to complete everything within that time period that I was there for the day. But I managed to do that, so that's a win. I can definitely say that I've improved greatly in my reflective comments, keeping up to date with that for the PPD side of things. And it has helped me to critically think more and realize what is more important and understand why I'm feeling a certain way and how I can solve those uncertainties and reflect that into my work ethic. Keeping up to date with my activity log allows me to keep track of the things that I previously did in a term. Two of my major difficulties I had was trying to get the analog reading from the moisture sensor, because it was quite a struggle to try to get it connected to the PLC. So that didn't work in the end. But then I tried it on my Arduino at home, and it managed to connect. So I think you have to use some special kind of sensors for the PLC. Another difficulty I faced was breaking all the CFL lights, but that was due to carelessness in my designs and just doing a half job whilst creating the clips for the mount of the lights. So that I should improve on in the future. Okay, demonstration. So yeah, that's why it was quite short and sweet.